All right. We finished with our ancient astronomers. Remember, we left it as Ptolemy's model, or his geocentric model. Earth was the center. Planets were all going around, and the sun were all going around the Earth. And they were going on these epicycles to account for retrograde motion. Okay? We're going to jump up to what we call modern astronomy. But before we get there, we have to learn something what we call planetary configurations. Because we have to know this to understand the next part. Okay, so what is planetary configuration? Think of this like moon phases for the planets. And with the moon phases for the planets, I have to make an adjustment on my camera here. It has to do with the relative position between the sun, the Earth, and the planet. So here we're going to do the sun and the Earth. So we're going to do it like we did with the moon. Sun is always on the right, Earth is here. And then let's pick a planet. Like we're going to do an inferior planet first, because they're different. Inferior planet means it's closer to the sun. It doesn't mean it's not as good as Earth. It means it's closer to the sun than the Earth is. So we have two of those. We have Venus and Mercury. All right, so let's do, this is Venus's orbit in here, or it could be Mercury, it doesn't really matter. It's not even close to a circle, but you get the idea. So if it lines up, so Venus is between the Earth and the sun, we have a special name for that. We call that inferior conjunction. Inferior because it's in between the Earth and the sun. Conjunction means that from the Earth, Venus and the sun are in the same place. And that happens when, remember, they're both going counterclockwise like this. So this Venus is passing between us and the sun. Now Venus goes around, it can also end up over here. When Venus is over here, it's also conjunction, because looking from the Earth, the sun and Venus are in the same place. This is called superior conjunction. And we have two more very special points when we look at Venus's or any inferior planet's orbit, Venus or Mercury. Notice that compared to the sun, as Venus moves around, it's going to get further and further, and the angle between the sun and Venus is going to get bigger and bigger. And then once it hits a magic spot here, it's going to get smaller again. So there's a point here where it has its greatest distance from the sun. And this is what's called elongation, or greatest elongation. In this case, this is greatest eastern elongation. Okay? And that makes a 90-degree angle up here between Venus, the Earth, and the sun, where the 90-degree angle is up here. That occurs when, if you remember your geometry class, that means that line is a tangent to the circle at that point. And that is when the maximum angle is. For Venus, that's in the 40s, like 47 degrees or so. So it gets about 47 degrees away, which means that Venus will set within 3 hours of the sun. Remember, the Earth spins at 15 degrees an hour, so as it's 47 degrees away, it'll take about 3 hours. Will you ever see Venus at midnight? No, you can't see Venus at midnight, at least from the equator, because you'll be over here, and Venus is always going to be on that side. Now, if you're up on the north pole of the Earth, far north, far south, then yes, you can see Venus even at midnight, but on the equator, you never will be able to see that. And vice versa, if we go down here, we have the by symmetry, the same thing down here. This is called greatest western elongation. And you may ask, well, why is east up there and west down here? Well, think of it this way. If Herb is standing here, so it's noon for Herb. Remember when we did the time here, east is up because that's the way the Earth is spinning, west is down. So you can think of it this way. Venus is east of the sun. And down here, Venus is west of the sun. But when it's in the eastern elongation, which is kind of confusing, when do we see it? We actually see it in the evening, and you see it best when you're up here around 6 p.m. or right when the sun sets. That's when you'll see Venus the best in the western sky, even though it's at greatest eastern elongation. So when it's up here, we call it an evening star. When it's down here, Venus is called a morning star. Okay? So when it's on this half of the diagram, we see it in the morning before the sun rises. Here we see it after the sun sets. And those are the same for Mercury. The biggest difference between Mercury and Venus is the angle is less than half or so. It's about 20-some degrees for Mercury. So it always sets within an hour or slightly over an hour from the sun setting. So even when the sun sets, by the time it gets dark, Mercury is very low to the horizon. So it is not an easy planet to see. All right. So what I want you to know these 4 positions. Just memorize those positions. All right, then we're going to do the same thing for what we call the superior planets. And remember, we're still talking from their perspective of, I'm going to start over because this diagram is getting complicated here, of the ancient people. So to them, a superior planet was Mars, Jupiter, and Saturn. However, we now know of Uranus and Neptune as planets as well. And truth is this works for everything in the solar system. Meaning asteroids. There's 700,000 asteroids, but they have the same configurations. Same thing with the trans-Neptunian objects, things like Pluto, Makemake, and Waimea, and all these other objects that are out there still orbiting the sun. So anything orbiting the sun will fall into these categories. So here's the sun again. Here's the Earth. Now I'm going to make the Earth's orbit smaller because we care more about objects beyond the Earth's orbit. So here is like Mars. Do Mars here. But it's the same for all the planets. So in this case, when Mars is in its orbit right here, so that the Earth, Mars, and the Sun make a straight line, we call this opposition. Why? Because look where the Sun is and where Mars is, they're opposite sides of the sky. This is just like being in a full moon position. Meaning when Mars is in opposition, it rises just as the sun sets. And vice versa, it'll set just as the sun rises. So it's up all night long. Not only that, notice that the Earth in its orbit is closest to Mars. So when Mars is at opposition is the best time to look at it. It's closest to the Earth, so it'll appear biggest in your telescope. And it's up all night long, so it's easiest to see. When Mars is over here, it's in what we call conjunction. Because it's in the same place as the sun is in the sky. We can't see it then because the sun is in the way. And when that occurs, we also lose radio communication with Mars. So when they sent the rovers to Mars and the satellites that are there, for a while there, while Mars is behind the sun, we can't communicate with them. Not directly because the radio signals can't get past the sun. The sun puts out so much radio energy that any signals coming from Mars would get lost. So for many days, everything is out of communication for a while. Same thing if you put humans on Mars. There would be a point when the Earth and Mars, or when Mars is conjunction compared to the Earth, that they would be out of communication. Then the other thing we can have is if we go straight up so that we make a 90-degree angle, if Mars is here or here in its orbit. Now notice this is different than the inferior planets. On the inferior planets, the 90-degree angle up here was on Venus, but here the 90-degree angle is between the Earth, the Sun, and the planet. This is called quadrature. fact, this is called eastern quadrature. And down here, this one's called western quadrature. All right, this is just like we were doing with the moon phases. And we were doing it before. We could actually predict when they would rise if we knew what phase, or vice versa, if we knew what time it was. We could put all that together. So I'm going to show you a problem that you will have on a test or on homework. It's just like we did with the moon phases, but now we do it with planetary configurations. So you just have to memorize these points. So a question I might ask is something like this. Say, Mars at opposition is setting well, Jupiter is on the meridian and Saturn is rising. What time is it? And what planetary configurations are Jupiter and Saturn in? All right, so